Okay, we will start. So in previous week, we evaluate this Fourier transform of this function, this e to the power minus a magnitude t, delta t, the unit impulse function Fourier transform delta t. And after that, we try to evaluate this kind of signal Fourier transform using our first principle, using the basic method, using that Fourier transform pair. So at that time, so for example, if we take this xt is equal to 1, this signal, we can easily integrate this function, the Fourier transformation integration we can do easily. But when we apply the limits, then we will face a problem. No, we can't evaluate that limits. Okay, so we have seen that in our previous session, using first principle to find the Fourier transform of this kind of signal is not easy. We can't say not impossible. Maybe some mathematical substitution, using mathematical substitution, sometime we can evaluate. We can't say it is impossible, but we have seen that it is somewhat difficult. Not somewhat, it is very difficult to find the Fourier transform of this kind of signal using the first principle, using the Fourier transform pair. Okay, so now you have learned some properties of Fourier transform. So using those properties, we can easily find the Fourier transform of this kind of signal. So we will see how to evaluate. So we will get this question first. Okay. See, xt is equal to 1. Okay. So we will get so we have a function xt is equal to 1. Okay, so we have to find the Fourier transform of this signal xt. Okay, so after find the Fourier transform of xt, that is Fourier transform of xt, we will have x omega, capital X omega, no? So we have to evaluate this. Okay, so in previous session, we have seen that using the Fourier transform pair, it is difficult to evaluate this problem. Now we will use property. Oops. So for this kind of signal, we can use duality property. Okay, so you have learned the duality property of Fourier transform. Okay, so I will remind it. So if we have a signal, xt, okay, if we have a signal xt, time domain signal, so this is a time domain signal, and if we get the Fourier transform of this signal, that is x omega, say it is x omega. Okay, so duality property said that if we have this kind of time domain signal, so understand this well. Okay, if we have this this structure, time domain signal, so this is a frequency domain. This signal has omega terms. Okay, this signal has omega terms. Okay, so if that omega terms is replaced by t terms, that means time terms. Okay, so that is again a time domain signal, no? So if we have this kind of signal xt, so this is again time domain signal. Okay. So this kind of signal we can get. So if we ask to find the Fourier transform of this signal, capital XT signal, so this is a time domain signal. So if we ask to find the Fourier transform of this signal, as usual, we can use the principal method, that is using the Fourier transform pair. Okay. So if we use the Fourier transform pair, okay, it will come like this. Okay. So we have xt, capital XT, that is a frequent time domain signal. Then we can integrate it to minus infinity plus infinity. Then we can uh, multiply it by e j omega t, then dt. So using this integral, we can find the Fourier transform of this xt. So we will get x omega. Okay. So it is say x dash omega. This kind of signal we will get. Okay. Okay. So, but so first using the transform, sometimes it should be possible to evaluate the signal, but here we are not using the pair, transform pair. So duality property said that this kind of signal we can directly get the transform, the Fourier transform, and it will come as 2, 5. So this is a time domain signal, and this t is replaced by omega. If this t is replaced by not omega, actually minus omega. Okay. So so again that is omega signal, no, x minus omega. Okay. So again this is a frequency domain signal. Okay. So the xt, Fourier transform xt, is equal to 2 phi x, this original signal, but the independent variable here it is t, and here it should be changed to minus omega. So this is the duality property. Okay. So sometime you may get confused it with the Fourier inverse transform. Okay. Actually, when I learned this first time, I have that doubt. So I feel that this is just like the Fourier inverse transform, but definitely it is not the inverse Fourier transform. Okay. So I will get the example to verify it. I think you can remember that we have evaluate the Fourier transform of this signal. Okay, xt e to the minus a magnitude t. Okay, I think you can remember last week we have evaluated. So here we have xt, simple xt. Okay, and that is e minus a magnitude t. Okay, so we have evaluated this Fourier transform using the first principle. So we will get x omega, that is the frequency domain signal. Okay, so we get it. I think you should remember this, 2a varga a square omega square. So this kind of signal we get. Okay, so you can see that here we have omega. This is our now our independent variable, and it is omega. That means it is a frequency domain signal. Okay, frequency domain signal. So if we ask to find the Fourier transform of inverse Fourier transform of 2a square omega square. So if we are asked to find the inverse Fourier transform, if we are asked to find the inverse Fourier transform of this signal, this omega signal, so what is the answer? What is the answer? So if you are asked to find the Fourier, this is, so you get the Fourier transform xt. Okay, so you have xt, Okay, so you have xt and you get the Fourier transform of xt, Fourier transform xt. Okay, then you will get x, you have got capital X omega. Okay, so this is capital X omega. So now you are asked to find the inverse Fourier transform of this x omega. So you are asked to find the inverse Fourier transform of this x omega. Inverse Fourier transform of this x omega. That means this function, this is x omega, capital X omega, no? So what is the answer? ඔකට දැන් xt වල Fourier transform එක හොයපුවාම අපිට එනවා x omega, omega domain signal එක. ඒක තමයි මේ තියෙන්නේ. හරි. x omega අපි කියවොත් එහෙම x omega වල Fourier transform එක හොයන්න කියලා. එතකොට අපිට එන්නේ මොකද්ද? inverse Fourier transform එක හොයන්න කියලා අපිට එන්නේ මොකද්ද? xt මයිනේ. So we will get xt here. Okay, so here we will get the Fourier transform, we will get x omega, and if we get the inverse Fourier transform of x omega, we will get xt. Okay, so that is why we have a two-side arrow. You see, we are using two-side arrow to represent xt and x omega. So if we get the Fourier transform, here you will get the Fourier transform. Okay, you will get the x omega, and if you get the inverse Fourier transform of this x omega, you will get xt. Okay, so here if you ask to find the inverse Fourier transform of x omega, so it is simply e to the power minus a t. Okay, so here it is a omega signal, frequency domain signal, and we get the inverse Fourier transform. Now it is time domain signal. Okay, understand? Okay, so this is the inverse transform. But if you are asked to, okay, so this is a frequency domain signal. Okay, so this is a frequency domain signal. I will write it again here. Okay, so try to understand this. Okay, so we have xt, and it is e to the power minus a magnitude t. Okay, then we have previously found the Fourier transform, and we got 2a square omega square. So this is the x omega signal, x omega. Okay, so this is omega domain signal. So if we are given a signal 2a square plus t square, so this is a time domain signal, no? So this is a time domain signal. So you have t as independent variable. So what you have done, this omega is simply replaced by t, time domain. So if you have this kind of signal, time domain signal, and you are here, you are asked to find the Fourier transform of this signal. Okay, then you are asked to, this is time domain. Okay, so you are asked to find the Fourier transform of this signal, Fourier transform of this signal. Okay, this signal. So this signal here denote as, so here it is capital X omega. So here I can denote it as capital X t, no? Don't confuse. So this is a time domain signal. Okay, so if you are asked to find the Fourier transform of this kind of signal, okay, what is the answer? It is not, we are not asked to find the inverse Fourier transform of this capital X omega. No, this omega domain signal inverse Fourier transform we are not asking to find. Okay, so we are asked to find this signal, this time domain signal Fourier transform. Okay, so in this case, you can use the duality property. So what's duality property said that? So you have to 5 and you have x minus omega. So this is the duality property. So what you should done? So here it is a time domain signal, and you have just change this variable t to minus omega. Okay, so that is the duality property state. So you will get the answer to 5 e to the power minus omega. Okay, so this is the answer. Okay, so please understand this. Okay, if you have any question, please ask. Okay, so this is the duality property. Okay, so we have xt signal. Okay, and we know the Fourier transform of this xt, that is x omega. Okay, and if we are given another signal, this omega, so this function is a frequency domain signal, but if we replace this with t, so we have this kind of signal xt. Okay, so this is a time domain signal, and if we are asked to find the Fourier transform again of this signal, so we will get 2,5 this signal with minus omega. Okay, so here we get the same answer. Okay, so you know that this absolute minus omega means again minus plus omega, so we can write this as 2,5 e minus a omega. Okay, so Fourier transform of this xt, okay, that is 2a square omega square. Okay, so if we get the Fourier transform of this signal, okay, so we will get e to the power minus a omega. Okay, so 2,5 with 2,5. Okay, so that is 2,5 x minus omega. So this is the duality property. Okay, so I hope you can understand it. Okay, so I think Dr. Udesh also has done has explained this. So you should be able to understand this concept. Okay, so now we are going to use the duality property. So I'm explaining the duality property, and I get a simple example to emphasize the use of duality property. Okay, so I hope you will not get confused from that. Okay, so if we have if you have this signal xt equal to 1, and you are asked to find the Fourier transform of this xt, so so one thing should come to your mind. Okay, so we have evaluated the Fourier transform of this continuous time unit impulse function. No? We have already evaluated, okay, using that property. Okay, so we will get the answer as 1. Okay, so if you get the delta t, okay, and if you evaluate the Fourier transform of delta t, that is Fourier transform of delta t, and you will get delta omega, and it is equal to 1. So this is, I think you can remember. Okay, the Fourier transform of delta t is 1, that is delta omega, that is 1. Okay, so so if you draw this function, it will look like this. I think you can remember, you should remember that if this is now omega signal, omega domain signal, and this is the delta omega, and you will get this kind of function. So here it is 1. Okay, so this is the Fourier transform of impulse function. So you will get this kind of function. Okay, delta omega is equal to 1. So here you have xt is equal to 1. So if you draw the xt function, okay, so now it is in t domain, time domain, and here you have xt. Okay, so it will like this, no? Okay, so here it is now. So this one and this one is identical. Okay, so you can use the duality property here. Okay, so you know the Fourier transform of delta t is 1. Okay, then if you get the Fourier transform of this one, okay, that is say it is like capital delta omega, like this. Okay, like this. Okay, so it is equal to 1, no? So if you get this kind of function, okay, so using the duality property, you can write it in as 2 5 x minus omega. So here x minus omega, x is delta, so you can write it 2 5 delta minus omega. Okay, so this is the answer. Okay, so if you get the Fourier transform of 1, Fourier transform of 1, okay, so this is in time domain, this is the signal. Okay, so this is in time domain, this signal. Okay, so you will get the Fourier transform as 2 5 delta minus omega. Okay, so you know that if you have omega, okay, so this is the delta omega. Okay, okay, so this is at 0. Okay, so if you get the time reversal signal minus omega, so again it is, there is no difference, no? So if you get omega delta omega, so you will get the same signal. Okay, so 2 5 delta minus omega is equal to 2 5 just delta omega. So this is the answer. So you can see that for 1, the Fourier transform is 2 5 delta omega. Okay, so this is the answer. Wait.